Yeah, all right, welcome back everyone. So we are getting to the end of our discussion on this aspect of normal distributions. Okay, so in this video we're looking at how to convert a normally distributed variable into a standard you know normal form. Okay, so now example. IQs measured in that's intelligence quotient. IQs measured on the Stanford revision of the Binet Simon intelligence scale are normally distributed with a mean of 100 and a standard deviation SD of 16. So determine the percentage of people who have IQs between 115 and 140. All right. So how do we do this? This is literally the question. So this is literally the question. So there's a mean of 100 and standard deviation of 16, so which means that okay, now the question says that we should look for um what do you call it, we should look for the percentage of people who have IQ between 115 and 140. So if you remember standard deviation, to this side these are positive numbers, so to this side you have 100 plus 16, I'll give 116 plus 16, but we don't have to do all of that. We don't have to do all of that. So what we just basically do is pick a value for 115, just pick a value for 115, pick a value for 140. Okay, so now we have to convert these values to this scores. Okay, so remember the formula that I said the z score formula equals to x minus the population mean, then this is divided by standard deviation. Okay, so we'll be having, let me draw the converted one here. So instead of mean of 100, we are going to be having a mean of 0. We're having a mean of 0. So it's literally the same thing, just trying to converting to this one makes it easy for us to get the area using our z-scores. All right. So for the first one, z1 is the first z-score z1. X is one number 115 minus the mean 100, then divided by standard deviation of 16. So z1 equals 15 over 16. How about our z2? Z2 equals 140 minus 100, now divided by 16, and this is equal to 40 over 16. So by the time we solve them out, so our z score, um so we have 15 over 16 is 0.94, and 40 divided by 16 about 2 point something. Okay, so that's going to be 2.5. 2.5. So now what we're trying to do here, so we now have two z scores. So for 115 we have 0 point, so we have 0.94, and then for the other one we have a 2.5. Okay, so what we are essentially looking at is the people that have um they have an intelligence quotient between here and here. So this is the area that we are looking for now. So you can see how important the previous class was. So all you just have to do is the area of the z-score of 0.94. Of course, that's going to be uh, on our positive z-score table. Then look for the area of 2.5, then subtract. So the area corresponding to area, let me just call it area of z. If you call this the z1 and z2. No, if we call this Z1 and Z2. So area corresponding to Z1 equals area of 0.94, that's 0.8264, 0.8264, and then the area corresponding to this called the second one, that's 0.9938, 0.9938. So the change in area, okay, equals 0.9938 minus 0.8264, and that's equal to 0.1674. 1674. So that's the area of that's the answer. But the question says, is how many percentage of people have IQs between 1.5 and 140? Okay, so 16.74% of the people have IQ between no. Okay. I'm sorry. Okay. No, that should be the answer now. That should be the answer. 0.8264 from this guy back. That's to the left. Then 0 points from this guy. Yeah, so that's it. So 16.74% of the people have IQs between 115 and 140. Okay, so that's it. The tiny percentage of people who have IQs between, so that's how you're going to conclude 16.74% of the people have IQs between 115 and 140. The other way you could like conclude is that the probability of selecting somebody who has an IQ between 115 and 140 is 0.1674. The probability of selecting someone at random who has an IQ between 115 and 140 is 0.1674. Again, the probability of selecting someone at random who has an IQ between 115 and 140 is 0.1674. Or 16.74% of the people have IQ between 115 and have I been saying 114? Sorry, 115 and 140. Settled. All right, so I think we have about two more questions to go, like of different kind. All right, we have the second question to deal with. Given that the average time to commute to work is 44 minutes and the standard deviation is 3.5, assuming the data is normally distributed, what is the probability that it takes A less than 40 minutes to get to work tomorrow, and B between 38 and 45 minutes to get to work? All right, so let's get to work. So I think it's not actually necessary, except maybe it's a theory question, to draw the the normal curves. But then to give a graphical representation of what we're doing, so let's just still draw it. So let's okay, we have this. So from the question, the average is 44 minutes. So 44 minutes. All right, and then it says we are looking for the parameter that it takes less than 40 minutes to get to work. So where do we locate our 40 minutes? 40 minutes exactly. Okay, 40 minutes is going to be after 44, right? So we can just use our standard deviation. 44 minus 1 standard deviation. So that's 44 minus 1 into brackets. Standard deviation was given as 3.5. 3.5. So that's 40.5. So the next number after this is going to be 40.5. And since what we are looking for is 40 minutes, so 40 minutes is going to be at the back of 40.5. Let's say 40 minutes happens to be here, okay, by assumption. So we are trying to look for the area of this place. That's what it's saying. I should look for the probability that it takes less than 40 minutes. So like area of this other place, and then speak with it in terms of probability. All right. So when we do the z-score, I think I can just put 0 here. Let's say we are converting this to normalized z-score, so like 0 can be here. Then so the probability that we are looking for is probability of you know probability that the person gets work in less than 40 minutes. So it has to be less than 40 minutes. Okay, probability that x is less than 40 minutes. X is less than 40 minutes. Okay, so now, converting this, remember our z-score, our formula. So we call the formula z equals x minus mu divided by standard deviation. So our x that we are looking at here is 40. 40 minus 44 divided by standard deviation is 3.5. So we have 4 divided by 3.5, and that gives us, is it 4? Okay, minus 4 divided by 3.5 rather. That gives us minus 1 point. No. Okay, yeah, minus 4 divided by 3.5 minus 1.14. So look at the z-score table, negative 1.1 under 0.04, and the area that is commensurate to that. So area of z-score minus 1.14, so equals to 0.1271. 0.1271. So since the question said that what's the probability that it takes less than 40 minutes to get to work, so the probability that it takes less than 40 minutes to get to work is 0.1271. 0.1271. So that's that. Um, or you may decide to like express in terms of percentage. So the probability of getting to work in less than 40 minutes is 12.7%. All right, 12.7%, and that's just it. Probability of getting to work in less than 40 minutes is 12. So then the probability is even is even like low. You understand? It's not that it's possible, but then it's not. I don't know how to really put it. Okay, it's the probability of it just happening is very small. It's just very small. Okay, so which means that I think 44 minutes is like really the real time that I can take to get to work or something a little bit you know a little bit away from me, but not up to like a 4 minutes gap. So there's a 4 minutes gap. Maybe you were held up in traffic a little bit, and then that 4 minutes gap, so just 12.710, let's say, probability of you to get to work. Now, B says, what's the probability of getting to work within 38 and 45 minutes? Within 38 and 45 minutes. So, like, let's do a graphical representation of that as well. So we have um 38 and 45 minutes. So this is still 44. Okay. So if this is 40.5 here, then for us to get 38, so let's go to the next standard deviation. So 44 minus 2 standard deviation. So 2 times that's 7. This will give us 37. Okay. Since standard deviation is 3.5, so 7. So this is going to give us. So we have here we have the 40, and then like the next one is like 37. Okay, can still extend 37. So since we are looking at 38 minutes, 38 minutes is probably here. So let's just say 38 is here. 38 is there. And then 45 minutes. So 45. So like 45 is probably just around 45 minutes. So we are trying to look for the area between here. So you can see why the understanding of what we did in the previous classes, okay, is important. So essentially, what we're just going to do is to look for the z-score of 45, like we've been doing before. Look for the z-score of 38, and then find their corresponding areas. Okay. So converting to z-score, this is going to be 0. Okay. Then using our formula, z equals, let me just enclose that there. So z equals z1, let me say z1. Z1 is 38 minus 44. 38 minus 44 over 3.5 standard deviation. Then z2 is 45 minus 44 over 3.5 standard deviation. So as z1 and z2, minus 1.71 and 0.29, minus 1.71 and 0.29. Please ensure that you are using your z-score table so that if I make any mistake, then you can easily correct me. Okay, so these are the z-scores. Now let us look for the areas of the two z-scores. Area corresponding to z-score of area corresponding to z-score of minus 1.71. Okay, is equal to 0.0436, 0.0436, and then area corresponding to z score of 0.29, 0.29 equals to 0.6141, 0.6141. So the change in area equals 0.6141 and 0.0436, and that gives us 0.5705, 0.5705. All right. So remember, the question says that what's the probability of spending between 38 and 45 minutes to get to work. So you want to express that the probability, okay, of 38 lesser than the value of x lesser than the value of let's put it like this. Okay. It normally it should be 38 less than or equal to x less than or equal to 45. Well, like just I think for some reason it's just left this way equals 57.1%. So the probability of spending between 38 to 45 minutes to work is 57.1%. So does that correspond with what I have here? Yeah, so that's it. Probability of spending between 38 and 45 minutes to work is 57.1%. So I think that brings us to the end of this particular video. Hope you've been enjoying your time on normal distribution, up to this present moment. So I think the assignment is, what is the probability that it takes more than 45 minutes to get to work? What is the probability that it takes more than 45 minutes to get to work? I think that's the only assignment that I have here. What is the probability that it takes more than 45 minutes to get to work? So okay, let me look for other questions. I was actually almost leaving before I came across something that I put in your assignment that I've not taught you yet. So let's just quickly go over it. Now, recall the IQ question, the intelligence questions, the intelligence questions question where the mean intelligence was 100, and then we had a deviation of 16. All right, so there's a third part of that question which says that obtain and interpret the 90th percentile for IQs. Now, obtain and interpret the 90th percentile for IQs. And what that basically means is that you are working under the area of 90%, or you are working with the area of 90%. Okay, like what is like the IQ that 90% of the population is going to have? Okay, so 90%, an area of 0.9, area of 0.9. Of course, we know if we were to bring this one here under normal distribution, so this would be 2.5 is what is here, 2.5% is what is here. So if you look at the 97.5, and that would be too much. Okay, so an area of 90 is probably around here. Okay, so that's what the question is, like 90th percentile, like looking at area of 0.9. So now what's this score do we have here? So so that's where the problem, that's where the problem starts from. What's this score do we have there? Now, what's this score corresponds to the area of 0.9? That's what you're gonna look at. So you gotta look at your this score table, and of course 0.9, you find 0.9 when you're looking at the positive z scores. And from what we have here anyway, this is 0. So number after 0 to the right is going to be a positive number. So like go to your normal go to your z score table and then look for 0.9. So we are going to be having 0.9. Are you done? Okay, I'm checking. I'm waiting. So this score corresponding to 0.9 is, there's this score corresponding to 0.9, area of 0.9 is 1.28. Okay, 1.28. So now, what is the intelligence, what is the IQ level associated with, this? Now, let me put this here. So we have a number that we are looking for. We have x. We're actually looking for x. Now this one, convert this one to like 0. So this score 1.28. So how then do we get the value of x? Okay, so we recall our formula. Our formula which says Z score equals what do you call it now? X minus the mean, the population mean divided by the standard deviation. Okay, we've been given Z. Now, from what we solved out, our Z is 1.28. So that's why it is good. We just this 0.9 was we use area is found with this scores anyway. So this area corresponding to this particular z score. Now this z score is corresponding to what value of x. So 1.28 equals x minus um 100. Right, that's where we should solve it, right? Minus 100, then divided by standard deviation of 16. So x equals 16 multiplied by 1.28, then plus 100. So x equals 16,000.28. That'll be around is it 20 or something? So that's going to be 20.48. So 20.48 plus 100. 20.48 plus 100 equals 120.48. So that means the value here of x is 120.48. Okay, so now the interpretation of this, because it says obtain and interpret the 90th percentile for IQs. So like only 10% of the populace have an IQ that is more than 120.48. Only 10%, because this is talking about 90% already. Okay, so only 10% of the populace have an IQ that is greater than 120.48. All right, and 90% of the populace have an IQ that is less than obviously. Okay, so yeah, now we're done. Now we're done. Sometimes I'm wondering why not only 90% of the populace have an IQ that is lesser or equal to 120.48. Like I said, I think there's something about that lesser or equal to, so like just interpret it that way. Only 90% of the populace have an IQ that is lesser than 120.48, and then 10% of the populace have an IQ that is greater than 120.48. So that's what. So obtain the 90%. We've obtained it 120.48, and then interpret two parts. Interpret, and that was what we just did. So now you can go fully into your assignments. You will see something like this. Okay, the assignments, the paper, like a research document, the paper water poverty in rural Nigeria explores water consumption in rural households. The data collected from a few houses has a normal distribution with 105 average liters of water consumption and a standard deviation of 69.8 liters. Determine the percentage of households that consume A between 50 and 100 liters, B less than 200 liters, and Roman figure 2. Obtain and interpret the 40th percentile and the 8th decile of water consumption. So I wish you the very best of luck. For MOG School of Economics students, of course, you know where to submit the assignment, and then you should be having more assignments, that are like this, as well as other videos that I've been referring to be having more assignments than the assignments contained in the videos. And what else? So next class we'll be looking at sample mean. So if we're able to cover that successfully, we are going to begin to talk about confidence interval and some other interesting things. So thank you for being with us so far. See you when I see you. Bye. Take care. Have fun.